So we'll move on to our next and final speaker. So I'm very pleased to introduce Sven Buehler, energy system engineer from Caterpillar, and he'll be presenting us a project in Germany. So the floor is yours, Sven.
Yes, good afternoon, everyone. Let me just share my screen. Let me know whenever you see the screen.
Yes, it looks to be in order.
Okay. So, yeah, my name is Sven Buehler. I'm working for Caterpillar and in the power industry for a little over 23 years now. For the last 10 years, really focusing on gas engines and combined heat and power applications. I just have a short slide on introduction of Caterpillar Electric Power. So we are a global leader in distributed power application with a traditional range of gensets, including diesel and gas. We keep investing to make those compatible with newer and greener fuels, such as renewable natural gas or hydrogen. But we're also expanding our product portfolio with alternative sources such as energy storage and, of course, bespoke packaging to allow for a seamless integration of our power generating assets in an existing site and connection to the utility, for example. Control is also a key component to ensure optimal operation and troubleshooting from a distance of the equipment, as well as our global network or dealer network to support products wherever they are. I'll be jumping straight into the case study. So I'll be talking about Lemgo Stadtwerke, which is a local utility. Lemgo is a small town in the north of Germany that is currently using district heating and CHP technology for a long time, and has always focused to achieve optimal efficiency of the district heating to save natural resources. Our local dealer, the Zeppelin Power System, has been a key partner of the utility to help Lemgo utility achieve their goals, and has been supplying over the years a number of different CHP installations that are distributed across the whole city. You can see there is over 18 megawatts of different power installation or CHP installation that contribute to provide the needed heat and power for the whole city. The city consumption is around 160 gigawatt hour per year, and the latest and award-winning installation was the supply end of 2021, and in 2022 has been commissioned of the 3 G3520Hs. So these are 2.5 electrical megawatt output gas engines that were combined and integrated, which was the key for winning this award, including with thermal solar farm of 5.2 megawatt and heat pump application to collect heat from the Bega River, which is the local river that was providing additional 1 megawatt of heat. To achieve this integration, one key milestone was to collect experience combining traditional CHP together with heat pumps, and this was achieved by our local partner, Zeppelin Power Systems by an upgrade in 2019 of an existing facility. And I'll be showing you now the details of the integration. So the unit that we are looking at here is a G3516H, providing 2 megawatt electrical power output that was installed as a classical combined heat and power system. So recovering heat from the engine and the exhaust, supplying roughly 2 megawatt of electrical power and 2 megawatt of thermal power. So in 2019, our local dealer upgraded this system with a first heat pump that enabled to recover the low temperature heat rejection from the engine, as well as a second exhaust heat exchanger to provide additional close to 800 kilowatt of heat that was then combined and supplied to a heat storage tank. In addition to that, a second heat pump in a two-stage way, though these are both ammonia heat pumps, was connected to the discharge cleaned water from the wastewater treatment plant. So this was used as a cold source, and the average temperature of the cleaned water is around 13 degrees throughout the year, and by cooling it down with 6 degrees, it's able to recover a little over 1.5 megawatt of heat, which, thanks to the heat pump, delivers 2.5 megawatt of heat to the district heating system. So this whole integration helped to really drastically improve the total efficiency of the system. A 2 megawatt G3516, if you consider the low heating value and ISO condition, consumes around 4.5 megawatt of or megawatt hour of energy as gas. And thanks to this, the two heat pumps, we are able to supply over 5.3 megawatt of heat, and of course 2 megawatt of electricity, which is partly used for supplying the heat pumps. All of the CHP installation in the city of Lemgo are operated based on the electricity tariff, so in a flexible way to really support the maximum benefit for the local utility, and the heat is then stored and used whenever needed in large storage tanks. So with this, just want to remind that, well, we keep investing in our product range to support customer meet their needs for reliable, affordable, and lower emission power supply. We have the expertise to integrate our products in very efficient ways. And thanks to our dealer network, we can provide you support wherever your project is located. So that would conclude my presentation.
Thank you very much, Sven. Again, another excellent example of integrating a CHP into an overall energy system to improve overall the overall efficiency of the system and bringing together different technologies working in tandem. So certainly at CWC, we see this as the future, where CHP works together with different technologies, different fuel sources, molecules, electrons, and the other speakers have also presented similar examples of how CHP works in a district heating system, but also operating flexibly, heat storage being an important enabler for further flexibility in the system. So thank you again to you, Sven, and thank you to other speakers, Jan and Alex.